we want to continue our course or lecture, and we will start to talk about mobility. In the first of chapter 7, we said that when we are talking about wireless networks, we should be clear about two main topics, wireless and mobility. We talked about wireless networks, generally speaking, okay? And now we want to talk about mobility and its related concepts, principles, and something like that, okay? The first question is this: what is mobility? When we talk about mobility, mobility means that a system can move, goes around in an environment, okay? From this point of view, we can say that a system may have a zero movement, or it may have or it may be a full mobile device. Okay, so I can say that we have a wide range from no mobility until high mobility. And then we can put our device in this range. For example, when we say that, okay, this device, this PC has zero mobility, it means that this device should be connected, for example, to a power point, to the outlet power on the wall, and I cannot put it on my back, for example, and move around my house, my office in the university, okay? A PC, a mainframe, a supercomputer is a device with no mobility, with zero mobility. But some devices has a small mobility capabilities. It means that it can connect to only one network provider. It means, for example, if you go to the Canada or to the USA, you can see that there are some special cell phones who are registered for only use in a specific cellular network, just for receiving service, for example, from a specific service provider, a specific cell phone telecommunication company. Okay, so some devices can only goes inside a wireless network. Some devices can moves between different access point, different base station, of a single provider, and some devices can moves all around the world, and still they have maintained their connections. For example, in current days, we hear several news about a Starlink network. It's a satellite network, and we can connect to Starlink satellite network all around the world. Okay, so if I have a network card to connect to Starlinks, I can use its services all around the world. So some devices, again, I repeat, some devices has no mobility, and some devices has high mobility capabilities. It's a wide range. Okay. Now, there is a main question. Okay, I have some mobile devices. Okay, that's true. But how a network should handle this device, because a mobile device can move around between different networks. So how should I handle it? How can I handle it? When my device leaves this network, its current network, and join into another network. So its current path, its current identity, its current IP address in the network is changed. So how should I control this mobility? How? Because the network should serve to that mobile device, but how? The first question, the first answer is this. Okay, let the network handle this mobility. Routers in the network, they can handle this mobility. Yes, it's a good answer. But why? But when I'm looking on, for example, Cisco statistics, Cisco says that in current days, total number of mobile devices are 5 times greater than total number of wired and fixed devices. Wow, it's great. We have multi-billion devices all around the world. They are connecting to different networks, and they are mobile. They should announce, okay, I am system X, my primary address is this, and I'm serving from that telecommunication company X, and something like that. Whenever they visit a new network, they should repeat their identity. Okay, it's a solution. Yes, they can do this, but there's a main challenge here. My device is changed its location. So what do you mean by new adnode? This is possible, yes, but why? I can't understand. What do you mean? Okay, new adnode. It's completely possible. If the transmission rate of your network is low, maybe need to spend, for example, more than 1 hour for that. The time delay for what? I think you are talking about the assignment, yes? Oh, I don't know. I should calculate. Should calculate it myself. You know, to find the answers. But I never think that this time is 3 minutes or something like that. I don't know. I should calculate. Should solve the problem myself to answer your question. Maybe in the future I solve it, but not now. Okay. Let's back to the course. So the first answer is that the routers handles the problem. When a mobile device moves to a new network, you should announce its identity, and to the routers in that network. Okay, so that router can handle it. The router can insert its identity, its information to its routing table, and so there is no need to change too many things in the router or in packet processing structure, packet processing process. In a router, in the routers, okay? But look at this. We have multi-billion mobile devices. It means that if I use this strategy, adding information of a mobile network to the routing table of each router, it means that the size of those routing tables can grow very fast. It can grow very fast. So that's impossible. This strategy is impossible. Okay? And in that case, if I accept this strategy, in that case, inside the routing table, we can see several records, maybe thousands, maybe 10,000s, maybe 100,000 records with the longest prefix, because the router should record the complete 32 bits IP addresses. If I use IP version 4, if I use IP version 6, the router should write the complete 128 bits IP address. It's not easy. And none of today's routers can handle this strategy. Why? Because when I'm adding, for example, I'm a mobile devices, I'm moving to a new network, so I'm announced to the router, okay, I'm system X, for example, and the router should register me in its routing table, and then it should announce to the other routers, okay, system X is here, is with me, and those routers should announce this to their other neighbors, and that's impossible. This strategy is not scalable. It means that I cannot use this strategy in large networks. Okay, I cannot use it. Maybe in a small network I can use something like this, but not in the internet. So I should look for something else. The other strategy is that we should let the end system themselves handle it. Only the end systems. It means that I should add a functionality to the edge of networks, not to the core of networks. I should keep this complexity far from the core. Okay, just I should look for the functionalities at the edge. In this case, we have two different strategies: indirect routing and direct routing. I will talk about them, but simply when I'm talking about indirect routing, it means that the correspondent start a call, a phone call, a network call, I don't know. The correspondent start the communication to the mobile node. This communication moves toward the home network of that mobile device, and then that home network redirects or forwards the packets, receiving packets, toward the mobile device in another network. The mobile device is visiting another network. He's somewhere else. So the home network forward the received packets toward the new address of the mobile network. This is an indirect routing. Direct routing, firstly, the correspondent gets the new address of the mobile device, and then it can directly communicate with that mobile device. Okay. But before going deep into these strategies, let me show this example here. Let's suppose that Alice is moving around the world. He is on a trip, okay? For example, he is going to, for example, Brazil or Argentina or somewhere else. And Bob, his lover, Bob, is looking for Alice. Okay, where is Alice? I don't know. Where is she? How can I find her? I miss you, Alice. Okay? Okay. What is your answer? How Bob can find Alice? Bob missed Alice, okay? So help him. Help Alice, help Bob. Let me know. What is your answer? Please write your answer here in the chat room. How we can help Bob to find Alice? What is your idea? Please write in the chat room. What is your idea? How Bob can find Alice? Alice is a mobile people. She travels around the world. Have you any idea how Bob can find Alice? Any idea? There is no idea. Okay. Bob can look for Alice from several using several methods. For example, maybe the Alice says that, okay, I'm in the home of, for example, X. So Bob can search for phone number of Mr. X in the phone books, and okay, this is the phone number of Mr. X, and Alice is over there. So Bob can call Mr. X home. Okay, it's a solution. Maybe someone else. The other answer is this. The Alice can say, okay, I'm here. For example, the Alice can send a message to Bob. Okay, Bob, I'm here. This is my phone, my new address, my new phone number. If you want, you can call me with this phone number. It's another solution. Maybe someone else, maybe Bob can call to Alice's parent. Okay, I'm looking for Alice. Where is she? The Bob calls Alice's parents. Okay, where is Alice? Maybe Bob look for Alice in Facebook, in Instagram, in WhatsApp, in Telegram, using social networks. I don't know. There are several methods that Bob can find Alice. But if you ask me, okay, which of these methods is better, I will answer you the best answer is to call to Alice's home or to her parents, because they should be aware, should be known where is Alice. Or maybe the other answer is, okay, Alice should announce me if I have if I want to communicate with Alice. First, Alice should announce, should report her phone number, her new address to me. Then I can call Alice. Okay. So here, when I'm calling Alice's home or Alice's parents, here, this home is important for me. Why? Because I know that Alice is a child of that house, so they know how they can find Alice. So always I can receive an answer. I can, for example, I can call Alice's father and say, okay, please send my message to Alice. I have a message, blah, 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 something else. Please send this message, my message, to Alice. Okay, the father can send that message. It's a way, it's a path to connect to Alice. Okay. Let me go back to the lecture. When I talk about mobility, maybe maybe the home of this concept of mobility is cellular networks. So let me start with cellular networks. How a mobile device is handled in cellular network. Look at this picture here, slide 57. My cell phone is registered in a cell. In a network. That cell is belongs to a network, to a special network. Okay. For example, I have a phone number from Tehran, for example. Okay. So my home network is Tehran network. My home carrier network is Tehran telecommunication network. So that's my home network. Okay. What is the difference between a home network and the other networks? When I'm moving to a new network, for example, I'm in Iraq. Right now, I'm in Iraq. Iraq is the network in Iraq is my visited network. But what is the difference between a home network and a visited network? When I borrowed my SIM card from Tehran, my information has been registered in databases of Tehran network. Okay, my identity, my service specifications, everything, and the Tehran network, the carrier in Tehran at the end of months, the Tehran network will account my billings, and they send the billing information to me. So I belongs to that network. My identity is defined in that network. But in Iraq is my visited network. Visited network is somewhere else. Maybe I'm in my home network. Maybe if I stand in Tehran, my visited network and my home networks are similar. But right now I'm not in Tehran. So I visit a new network. I visit a new network. I receive services from in a new network, in the visited network. So one main question. Okay, my home network is Tehran network, and I'm in Iraq. I'm receiving this service. Still, I'm receiving this service. How this should be? How we can handle this? My identity, my information, my service plan, everything is registered and stored in databases in Tehran, not in Iraq. It means that I need a gateway in visited network. That gateway is responsible to announce to my visited network, okay, this phone number, this system is here, is with me. So let me know him. Is he an authenticated user? Yes or no? Can he receive new services? Yes or no? What is his plan? So to visit the network, we have a gateway. Through this gateway, I can ask my home network, they can ask my home network, okay, what is the specification of service of this user? And look at this here. When we talked about a home network or a visitor network, that network consists of several cells. It means that in the architecture of a wireless cellular network, I have several different cells. Those cells are handled and managed using a central management system. Okay, a central management system would handle them. And look at this here. So if I change my base station, my antennas, inside a visited mobile network or inside my home network, there is no difference between them. I don't need more information. When I move from a home network toward another network, we call it roaming. So roaming is changing the home network with another network. Maybe you hear this word. For example, most of times when you are going to the border, to the country's border, in the country borders, maybe you receive a message. Okay, for example, welcome to Iran telecommunication network. Oh, I'm in Iraq, not in Iran. What happens? For example, or maybe in Iran, you receive a signal from an Iraqi telecommunication company. We call it roaming. Your device find that there is a stronger signal received from another company. So my device, my cell phone, joins to a new network. This is a roaming. Okay. The home network and visitor network can connect together through the public internet or through private platforms. I don't know. I'm not sure about that platform to connect the visitor network and to the home network. Okay, but I'm generally talking. My device, my cell phone, leaves its home network and joins to a new network. Maybe someone says that, okay, how, when I'm, for example, I'm moving from Iran to Iraq, how my cell phone can be identified inside Iraq? How? The answer is easy. I have a SIM card on my cell phone, and that SIM card, the ID of that SIM card is unique. So simply, the network can identify who am I. Maybe in the intelligence movies, intelligence services, maybe in the movies you can see that, okay, you should left your cell phone, you should drop your cell phone because they can track you. How? Just using your identity inside your SIM card. And there is another identity inside your cell phone. So they can track you always. It's easy. Okay, it's easy. Just I need to access to a cellular network to find you. Where are you? That's easy. Okay. However, this is a scenario in a cellular network, in a 4G or 5G networks, but we have a similar conditions to move from one ISP to another ISP. And again joining to Wi-Fi's, different Wi-Fi's. Then how can I handle this? It's another interesting scenario. My laptop here, my device, can attach to this network or to this one. It's not important for me. Just the only things that I need is that firstly I should register into a server in the attached network, and during this registration, that that network will authenticate me. Who am I? So simply I need to enter my ID, my password, my usernames as the ISP request from me. Some ISPs are prepared this service, prepares this service that you can receive Wi-Fi services all around the country. Okay, so we can receive a similar structure, same as, for example, 4G network, because my device is leaving one network to entering a new network. So, if we forget the technology, going back to the basics. So I have a home network, a visited network, and a correspondent who is looking for the mobile device. And this is my device, my mobile device. This device belongs to this home network, but right now it moves to a new network, to a visited network. When my device is in the home network, this device has a permanent address, has a permanent IP address. Look at this, but this device moves to another network. Its address is changed. And this is true because inside a network, the whole devices inside a network should receive the IP addresses in the range of the IP addresses of that network. We talked about it in chapter 4. Okay? So, my mobile device receives a new IP address. Its permanent address is changed in visitor network. And we have visitor network gateway here and home network gateway here. Here you can see in the visitor network we have a mobility manager server. In the home network we have a mobility manager server and also a home subscriber server. For the first time, when I'm attaching to my home network, my information will be registered in the home subscriber server. All of my information will be registered in that server. And when my device moves to a new network, the mobility manager server, this server here, handles this movement. So the mobility manager is responsible to handle the mobilities, okay? Through these two gateways. If you remember, when I start to talk about mobility, I said that I should put the complexity of handling mobility at the edge of networks, not in the core. And here in this image, you can see that. Just we draw a blue cloud and write, okay, it's a public or private internet. It's not, it's not important. What is this? Why? Because I'm trying to handle this mobility at the edges, not in the core. And my correspondent is somewhere else. Is somewhere else. And now, my device moves into a new network. Firstly, it should register itself to the mobility manager. Okay, I'm new in the visited network. This is my identity, and please give me an IP address here. Okay, so my mobile device talks with the mobility manager, and that mobility manager here, in the second step, that mobility manager start to contact with the home subscriber service in my home network. Okay, someone stands here and it says that my home network is somewhere else. Is for example, is somewhere else. Are it true? Is it true? Is it right? This device belongs to you. It's a part of your network. The mobility manager asks this question from the home subscriber server. Is this device right? It tells that my home network is over there. Is it true? So the mobility manager asks this information, and at the same time, he registers information of the visited mobile device inside itself, and he announces this information to the home subscriber server. It's a registry processor. Using this strategy, my home subscriber service will know where am I. It will know where am I. It knows my location. Where is my location? Okay. And when we talk about an indirect routing, it means that the correspondent will look for my mobile device. Okay. They start to communicate with the home network gateway. Okay, I'm looking for system X. He's inside. He's in your network. The home network gateway will look for the receiver. Oh, the receiver is not in my network. It moves to somewhere else. So, then home network gateway will forward the sender's packet to a new address. And this address and this packet in the visitor network, this packet will receive to the mobile device. So here we use an indirect pass. The correspondent asks from the home network gateway, and home network gateway will forward the packets to the visited network gateways and network gateway, and then it receives to the mobile device in the visited network. What about the answer? The mobile device can answer in two different ways. He can move his packets through the primary pass, passing the packets from the visited network to the home network, and then moving to forwarding those packets to the correspondent. Or maybe an easier solution is that his device can send its information to the visited network gateway, and that network gateway can directly communicate to the correspondent. So we have something like a triangle. So we call it triangle routing because it's similar to a triangle. Okay, but we know that this process is not efficient because always I should send information to the home network, and that home network should forward the packets to the visitor network, and then the visitor network can forward those received packets to the destination, to the mobile device. And maybe the answer is forward directly to the correspondent. So this strategy is not efficient, especially when both the correspondent and the visitor, the mobile device, are standing in a similar network. For example, I'm here in Iraq, and Dr. Rahman is in Iraq too. But my phone number, the home network of my phone number is Tehran telecommunication company. If I use this strategy, it means that when I'm calling Dr. Rahmani, my call would forward to Tehran because it's my home network, and then it forwards back to Iraq. But both of us in Iraq are in Iraq. So why I should send information to Tehran and Tehran back to Iraq? Why? This strategy is inefficient. Okay? But this strategy has a positive point. Why? Because always I know that where is the mobile phone. Where is it? And I know that always I can find the answer in the home network, because when the mobile device changed its network, using that mobility management service, my new location would be announced to the home network. Okay. So always I need, if I'm a correspondent, always I need to call it to call to the home network. I'm not care where is the mobile device. So this strategy is completely transparent, because the address of the home network does not change during the time. So it's transparent. I always send information to the visited network, to the home network. And that network will forward my packets toward the destination, toward a new destination. And that is interesting. I can make a connection, a TCP connection to the correspondent. Even when I change many things. The other solution is this. When the correspondent starts to search the mobile device, firstly, it can ask from the home network, okay, I'm looking for System X. Where is he? Where is it? Please give me the IP address of it. So, in the first stage, I received the latest IP address of the IP address of the mobile device. And then after that, the correspondent will forward its packet directly to the visited network. It will send it directly to the visited network. This is a direct routing strategy. So in direct routing strategy, you cannot see a triangle. Okay? So it's a better solution rather than the triangle strategy, which is inefficient. And maybe the routing, the direct routing is not transparent. Why? Because my device left its network, so it changes everything. Especially, you should receive the care of address from the home network. What is the care of address. The address in the visitor network is the care of address. We call it care of address. So care of address is received address in the visitor network. Maybe someone says that, okay, I accept your your strategy, but I'm in a visitor network and now I want to move again. I want to visit another network. What should I do? Again, I can say again. The edge network should handle this movement, the new movement. So again, we need some additional complexity in the system. Okay, let me talk about mobility in 4G networks because it's dominant. The 4G is dominant in the network in the world. As I said, in the home network, I have a home subscriber server and a gateway, P gateway or S gateway, something like that. And here you can see in the visitor network we have a mobility manager server and a base station which is connected, which can connect to the mobile device. So here we have a base station association strategy. Then we need control plan configuration. The third one is data plan configuration. And the fourth one is mobile handover. These 4 items are the main tasks in mobile 4Gs. But maybe someone asks me, okay, what is the handover, mobile handover? Mobile handover or handoff? Handover or handoff? Handover or handoff? Both of them are similar. Handover or handoff means that leaving one network and entering to another network. If you remember, we have a roaming. But roaming means that I'm leaving network of one ISP and entering to network of another ISP. Okay. In handover, just I change my network, my cell handover or handoff is related to changing my cell, my base station, leaving one cell, entering to another one. It has a big difference between handover and roaming. In roaming, I'm changing the network completely. So here you see 4 different major mobility tasks. For example, when I'm talking about data plan configuration, it means I should plan for the movement of packets of data from one network to another one, from home P gateway to the mobile device in another gateway. And when we are talking about control plan configuration, we're talking about controlling this network completely. I'm not care about a packet. It's something else. And also, we have a base station association strategy. In base station association strategy, my device, my mobile device, enters into the visitor network. So firstly, it should identify itself. I am Mr. X, comes from network Y, something like that. Okay. So during the base station association, the mobile device will announce its information to the visitor network. This is the structure of handling mobility in 4G technology. In LT, what is in LT? Let me. Okay. How we can act based on these different tasks? For example, in LTE, when we want to configure the control plan of LTE, this is the structure of LTE here. When we are talking about the control plan in LTE, firstly, the mobile device should communicate with the MEM or mobility management server in the visitor network. Via the base station control channel. Okay. The MEME will use the IMSI ID of the cell phone. So the MEME will contact to the home's device. It will retrieve the authentication information, encryption, network service information, everything. It will ask from the home network, what is this and how should I handle it? So in control plan, we have to be careful to connect the new device to the network and send its information to the visited to the home network, to the responsible of home network. And finally, the base station and mobile device should talk to each other, communicate to each other to set their parameters. Okay, and when we talk about data plan tunnels in a cellular network, we have several tunnels, three different tunnels in LTE. One tunnel between the S gateway and the BS to the BS tunnel. This tunnel from S gateway to BS is a tunnel that we use it when the mobile changes base station. So simply we use this tunnel for the IP addresses at the endpoint. Okay. The other channel is channel between a tunnel between S gateway and P gateway. The tunnel between the S gateway and P gateway, as we talked in the last slides, is a connection for indirect routing here in the image. We use this tunnel to forward information toward the visitor network. Okay, for indirect routing. And when we talk about tunneling, we have GTP. GTP means GPRS tunneling protocol. It's a tunneling protocol. We can use it, and sending information to a stream server. Here, let me show you the GTP. Here, this information should be sent from the mobile datagram streaming server, from the mobile device into the server, to, for example, the streaming server. Okay. So we have three different tunnels in data plan of a cellular network in this way. Something between the SGW, S gateway, and the base station here. Another tunnel between the S gateway and the P gateway, and create a tunnel via GTP. And how we can hand over between two different antenna or two different base stations inside a wireless cellular network. For example, here we have two different base stations, and this device wants to move from source base station toward the new base station, toward target base station. How it can be possible? To do this, the source base station, according to the movement of this mobile network, the source base station will select the target base station, and then it will send a handover request to the new one, to the targeted base station. This targeted base station will allocate different items. For example, allocating a radio channel, radio time slots. Okay. And it will announce this allocated information to the source base station. These two steps, step number 1 and step number 2, during these steps, those base stations, source base station and the target base station, tries to communicate with each other, and the source base station will ask this target base station, okay, I have a user, he's moving toward you. Okay. This device has these specifications, this requirement something like this. And what do you think? Can you accept it? If the target base station say, yes, I would handle it, then source base station can understand that, okay, a handover can be take over. Okay, it can happen because the target base station can allocate those requirements, but this requirement is a pre-allocated radio channels. It's a pre-allocated. Then it will announce to sources base station, okay, I'm allocating the sources. Let the mobile device to know to hand over into me. Okay, changes base station from you to me. So the source base station will inform the mobile device, okay, it's time to go. You should move to another base station. You should join to another station. You should hand over to another station. And during this handover, the source base station will look completely for this handover, leaving the base station, the source base station area, and joining to a new base station. The source base station will look for this process. After the completion, the source base station will stop everything, will remove the allocated sources, will remove everything. Why? Because the mobile device is standing with another one, with another base station. So it can simply remove every allocated resources to handle a new device. Maybe someone says that, okay, why the target base station pre-allocates everything and then he said to the source base station, okay, it's time to go. Let the mobile device join me. But why? Most of times when we are talking, for example, I'm talking with my cell phone and I'm moving, for example, moving inside the city from one city to another one. During this movement inside or outside the city, I'm talking with my cell phone, and at the same time, my cell phone handovers from one base station to another one. It joins to the target base stations. Okay? And during this process, this handover, there is no drop in my cell phone, my communication link. So the target base station should firstly pre-allocate everything, pre-allocate the requirements, and then it says to the source base station, okay, it's time to go. Let's move the mobile device from you toward me. And when the cell phones, my mobile phone, tries to join to the new base station, it can understand and find that, okay, the target base station is standing for me. He's ready to accept me. He's pre-allocated everything for me. The only thing that I need is just to say, hello, target base station. That's it. Everything is finished. The target base station will pre-allocate the resources. So I don't need to look for those resources. So my cell phone will hand over or hand off at the same time that I'm moving across the street. And I never found that the cell phone hands off or hands over. I never understand that my cell phone changed its base station. Everything would happens in the background. Okay? Everything. Just I receive my information. It's an interesting mechanism, this handover or handoff. It's very interesting in wireless network, especially in cellular networks. Just I need to change this. Look at this. After this one here, when the base station says, when the source base station says to the mobile device, okay, it's time to go to the new base station, and at the same time it sends a packet, sends a message to target base station, okay, be ready, the device would arrive in a few seconds, in a few times, very soon. So make configuration in your systems, in your make changes in your configuration, and then at the same time this target base station would answer to the source space, the source base station, okay, I'm ready. And at the same time, okay, this one, number 3 and number 4 are doing at the same one, and this mobile device will ask the target base station, okay, I want the old base station says that I should connect to you, and this base station will say, okay, welcome to the new base station. And after this migration, migrating from one base station to another one, simply I can communicate through the new base station. The flow of my traffic will change to a new tunnel. For example, in the past, this system sends information from the source base station and using this through dispatch, and after the handover it sends information through dispatch here. But maybe someone says that, okay, how you can find that which base station is better than the rest? Choosing the best base station is something complicated. We are omitting it, but you can look for that. But mostly, the new base station is a base station with the strongest signal. So if a mobile cell phone receives, for example, signals from 3 different base stations, it can choose the strongest signal and then ask for handover to that one. It will ask from the source base station, okay, your signal is weak. And the base station will receive those information, okay, the signal is received, and but I received this information from 3 different base stations. And then the source base station will think about those movement and giving one base station joining to another one. Okay. Mostly the criteria or the metrics for this handover is signal strength. We talked about signal strength in the past lectures, in the past sessions. Okay, that is enough for today. Is there any question?